Hello everyone, in this video we'll be solving problem 242 Vanity Anagram. Given two strings S and T, return true if T is an anagram of S, else return false. String A can be an anagram of string B if A can be created using the characters in B by rearranging them and using each character exactly once. If we look at example number 1, string T can be constructed using all of the characters in string S. Hence the output is true. But in example number 2, T is not an anagram of S as the character C does not exist in string S. Hence the output is false. I hope you are able to understand what anagram means and what the problem statement is asking us. Let's switch to whiteboard and discuss how it can be solved. Let's take the example number 1 as our input. The simplest way to solve this problem is using Hashmap, where we iterate through one of the strings, identify all of the characters and save it in a collection with its corresponding character value and count. After that, we'll do another iteration on the second string, compare each character against this collection, and if the value exists, decrement its corresponding count, and if it does not exist, return false. Let's run a couple of simulations to understand how will this work in action. We'll start by iterating the string S1 and saving it into the collection. After going through the iteration, the collection would look something like this. Now we'll start the next iteration to compare each character in S2. Starting with I is equal to 0, corresponding value is n. Does it exist in the collection? Yes, it does. So we'll decrement its corresponding count. As the value of n will be 0 after decrementing, we can remove it from the collection. After removing it, we'll increment our I pointer and continue forward. With I is equal to 1, the value is going to be a. Does a exist? Yes, it does. There are 3 occurrences, so we'll decrement its value to 2 and continue forward. Now our I will become 2. It's pointing at G. Does G exist? Yes. So we'll do the same operation. We'll decrement it by 1, and as it is now 0, we'll remove it from the collection. After we have iterated through all of the characters in S2, this collection should be empty if the two strings are anagram. If this string is not empty, it means that there were characters in S1 which did not exist in S2. So we should return false. And also when we were iterating through S2 and we encounter any character that does not exist in the collection, it means that there are characters in S2 which are not there in S1, which implies that S2 and S1 are not anagram of each other and we should return false. With this solution, our time complexity is O of m plus n, where m is the length of S1 and n is the length of S2, as we are iterating through all of the characters in S1 and S2 one after another. And the space complexity is O of 26, as there are a total of 26 alphabets. Even if the length of S1 or S2 is greater than 26, the collection size will not grow more than that. I hope you were able to follow the explanation. Let me show you how we can implement this using C#. Here is the C# solution. I start by checking if the length of S and T are not equal. If they are not, then we can simply return false. I then initialize a dictionary of type character and integer. I then start a for loop on string S and saving all of the characters in it into the counts dictionary. I then start another for loop on string T to check if each character exists in the counts collection. If it does not exist or its corresponding value is 0, then I stop the iteration and return false. And if it exists or the count is greater than 0, then I'm decrementing its corresponding value. This code, when submitted on LeetCode, beats nearly 74% of the submissions in terms of runtime and 58% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation and the code. The link to the code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.